Okay, so we're gonna do number 17. We're gonna first do it with desmos, and then we're gonna do it with algebra because you can do it with both. Um, so number 17 says y equals 6x plus 18. One of the equations in a system of two linear equations is given. It's given right here. This is the first equation of the system. The system has no solution. Which equation could be the second equation in the system? So we're supposed to choose from these four, and the other equation is going to be the second equation in the system. What is the characteristic of these two equations? The system has no solution. So remember, no solution means there's no intersection between these two lines. So that means they would have to be two parallel lines, right? If there is one solution, that would be the two lines intersecting at one point. And if it was infinite solutions, that would be the two lines on top of each other. Okay, so they're saying no solution, so that means parallel. So when we do this with desmos, all we need to do is type in all these equations, or at least the first equation, and you type in the second set of equations until you find the parallel one. We're just looking for the parallel one, right? The no solution one. Okay, so let's type in the first equation, y equals 6x plus 18. And it's this purple line here. And then I'm going to type in option A, which is negative 6x plus y equals 18. Oh, it's the same equation, right? So this is the one that's infinite solutions. We don't want that. Then we type in B, which is negative 6x plus y equals 22. Oh, okay, so this one's parallel. So the answer is B. We don't even need to type the other two in. Okay, the answer is B. Now let's do this with algebra. Okay, if we're going to do it with algebra, basically, like I said before, we're looking for the parallel line to this one, right? The tricky thing about this is given in slope-intercept form. Since it's in slope-intercept form, we can easily see that the slope is 6. These are not given in slope-intercept form. These are given in standard form. So standard form being, like 3x plus 5y equals 7. So there's like x and y both on the same side. They each have a coefficient. Y is not isolated. These look like y is isolated, but it's just because the coefficient is 1. And then you have this extra number over here. So the thing about standard form is it doesn't obviously tell you the slope just from looking at it. It doesn't obviously tell you the y-intercept from looking at it. So it's kind of a useless form. Very good for testing. They can like hide the slope and the y-intercept by putting it in standard form. So we're just going to change all these standard form equations into slope-intercept form so that we can see if the slope is 6 or not. So for this first one here, we want to isolate y to change it into slope-intercept form because that's the characteristic of slope-intercept form, which helps us do the algebra to get there. We put y by itself on the left side. So if we have y by itself on the left side already, we're going to add 6x to both sides. We'll get y equals 6x plus 18. We can see that it's the exact same equation, so it's not parallel, it's the exact same equation, so it would be infinite solutions, not no solutions. And then for this one, we'll do a similar thing. We're going to add 6x to both sides. Then we get y equals 6x plus 22. And so now we can see, oh, okay, this one is also the same slope, 6, but this one is not the exact same line because it's not y-intercept of 18 is y-intercept of 22. So this is the one we want. So we can see that B is the answer. Now these ones down here, we can see that we would add 12x to both sides to get y by itself. So we'd have y equals 12x plus 36. We can see this is clearly wrong. It's not parallel. 12, slope of 12 here, slope of 6 here, not parallel, right? Same with D. All right. So that I showed you how to do it with desmos. I showed you how to do it with algebra. Probably people who could do this mentally and just look at it and just do this in their head and see that the negative 6x would go over here and would be a positive 6x. That would probably be the fastest way to figure out which one is parallel, faster than typing it in Desmos, right? And that's kind of the philosophy of the SAT recently. They want to make the problem even faster to solve for someone who doesn't need Desmos and can just do a little bit of mental math or mental algebra.